Another one I want to show, last class we have finished that boring log network, how what is the boring log data, how to represent. Just want to show, look at this picture, this is a proposed plan of this site, and this way this construction has to be made. This is a top view, plan view, you can see, look at the top view, and this is your top view of this proposed structures. So, generally what happened, if this kind of building or multi-story building, once it has been planned, generally what happened, borings, how many number of bores and where to be done, it has to be decided first. So, in this case, this is your borehole 1, borehole 2, borehole 3, borehole 4, borehole 5, borehole 6. If you look at here, every corner of this proposed structure, every corner this boring has been proposed, and it is up to the design engineer or it is up to the geotechnical engineer to decide how many number of boreholes to be done. But generally this is the generally in the corner, if this kind of proposed plan maybe structure, you can go for 1, 2, 3, 4 corners. However, my concern is sometimes after seeing this boring log data, say 1, 2, 3, once you have done boreholes and collect soil samples from these boreholes and test in the laboratory, after doing this, if you found that these soil profiles are not same, the soil profiles are varying from one location to other location, other location to other location. In that case, you may include more boreholes at the center. This is just a there is nothing straightforward rule. This is a thumb rule. Initially you plan for 6. After seeing this boring log data of the 6, if you see this soil profile is varying from one bore log to other bore log, then you may decide additional boreholes may be carried out at the center of the proposed plan. This is your proposed plan of the structure, at the center, additional one, additional one, additional one. Similarly, if this is my proposed plan of a square or rectangular shape, after doing 2 boreholes and conducting the test, you may decide also at the center. So, what will happen once you decide at the center, you will get a soil profile data not only around the periphery, the basic reason behind it where you want to do this proposed construction. Generally you go around the periphery of the proposed structures, because these foundations, it is supposed to be the foundation will be lying here, column and beam will come at the corner, maybe at the center, at the periphery, so that you will be knowing what is the soil profile. So, this is generally in practice people do, but once you recommend, if you see that this soil profile is not of uniform or it is varying from one borehole to other borehole, then you decide you may go for additional borehole at the center of the proposed plan. Then what you will get? You will get overall idea in this proposed plan, in this particularly in this proposed plan, how the soil profile vary across the 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means around the periphery and across the center, how much variation you are getting the soil profile. Is it a large variation? Is it a small variation? If it is a large variation, how to interpret? You will have to take average value or you will take most adverse conditions for the design point of view. These are the considerations, generally it depends upon the design engineer. Suppose say in this case borehole 1 and in this case say 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8, 9. Suppose say borehole number 1 you are getting a silty sand kind of profile. Across this you are getting a silty sand. Now here if you are in the 7th number of borehole you are getting a mixture of sand, silt and clay. Now it is up to you to decide which parameter you are going to consider, particularly this part of footing. Means footing, definitely if there is a column, there is a footing here, there is a foundation here, there is a foundation here, if this is a proposed structure. Now, whether you will take most adverse condition or you will take more easiest one. That means, if you take sand kind of things, maybe footing and footing load, whatever you are getting, depth of the foundation will be very shallow. If you are going to consider this kind of, if there is a clay, so that means the plasticity index will come into picture, and liquid limit, plastic limit, and all this fine grained property will come into picture. Based on that, the strength property C and phi will change. Whether you will consider this or this, generally you will go for most adverse conditions for this design. This is about, I show you how you decide this boring, where you have to do the boring, and if required how you will decide your additional number of boring to be done. Now, come back to another interesting one. There are different type of annexure you can provide in soil classification. If you look at here, earlier I have shown last class about the data lugger or borehole luggers, how the data has to be provided. In some cases, how they provide, if you look at here, depth they have written, the ground they have written, where is your water table, first depth, this is your ground water, where is your water table lying, first column. Second column is your depth, this is your depth in feet or meter, and third column is nothing but is your classification of soil. As per your testing from laboratory and field, you can classify it. Then samples, at what depth you collect undisturbed sample. If you look at here, I also explain here, at this depth, this sample has been, undisturbed sample has been collected. If you look at here at the right side, natural moisture content versus your SPT value, variation of SPT value, instead of writing N, earlier I saw that you sum column, you write only value of N, penetration value. Instead of writing N, if you show the variation of penetration value along the depth with your, what is your natural moisture content you collect, if both the variation, if you show it, that will be a great, particularly you can decide where you can lay your foundation. If you look at here, this triangle, this is your standard penetration recorded up to depth of 36.5 feet. Instead of writing N, suppose here N is equal to 11, N is equal to 15, instead of writing N value, I want to show a plot, how the plot is varying over the depth. So, what is this advantage? In a first instant, the site engineer, design engineer, he can see, instead of taking N value, he can see how the profile varying. If you look at here, almost N is constant between the depth of say 2 feet to 20 feet, the penetration value is almost same. That means this, what does it mean? If N is a kind of constant, that means, what does it mean? That means the soil is same, the kind of soil you are getting, it is same. If you look at the classification says also same. It says medium dense molted red, brown, yellow, black, silty medium sand with fine gravel and moist. Look at here, silty sand is available from 2 feet to around 18.2 feet, and it confirm whether your SPT value, means if there is any mistake either in soil classification or in SPT, it will, you can confirm seeing this profile. Suppose there is a mistake in soil classification doing in the laboratory, suppose here it is silty sand, some depth you will get some sand. So, it is not possible that this over the depth the N value should be constant. Look at here, n is 11, n is 15, n is 10, n is 15, means value n value up to this depth up to 18.2. If you look at 11, 15, 10, 15, means almost n value is varying between 10 to 15. That means it cross check, it completely cross check whether your laboratory tests are correct or not. Again, suppose your laboratory test you are getting up to this 18.2 meter depth, you are getting this laboratory test. From there, suppose you get kind of silty sand. If this meter depth of silty sand is there and there is no water table, of course, if there is water table, definitely n value will change, because this water table correction will come into picture. So, if there is no water table, that means your field penetration value should be kind of more or less it kind of same. So, this reflect this data whatever done in the laboratory and field, they each other supplement, that means they are the correctness of these data are very good or excellent, you can say. Then look at the moisture content profile, natural moisture content, as I said earlier. So, how much water present every 2 meter depth or 2 feet depth, how much water present inside the soil. If you look at this, again this moisture content also almost consistent, it kind of constant. Here it is varying, water content is say 48%, 47%, 46%, 45, 46%, almost it is also consistent. So, this way preparing a data logger in this way is a more better way to represent, and it will be very easy to extrapolate. If somebody can first instant somebody can visualize, he can say how the penetration value varies, and based on the penetration value what should be your strength value, that can be indirectly you can interpolate or extrapolate. Now, if you look at here, it has taken a bigger one. You see standard penetration, blow count and water table has been shown, and your SPT has been shown. You can show it, you can take it out and show outside also. You can put it annexure 1, you can put it annexure 2, so that you can visualize. You see first SPT has been done at 1.3, then 554, 39, these are all SPT value, and undisturbed U for undisturbed sample has been collected, and here you are showing that how your penetration blow, how it is varying, that you can clearly also show for different cases. These are the two things I have shown you. One is, this is the thing I have shown last class. This way also you can report, that means column 1 is your depth, second is your sample, third is your sample number 1, 2, 3, 4, 5. Then you can show blow on sampler, that means you can show that 3 blows, means how the SPT has been done. Sometimes the design engineer also ask, instead of showing n per 30 centimeter blow, you can show entire n count. What they will do, this is your n, simple they write n, this is your sample blow n. So, what they generally they put it 15 centimeter, 15 centimeter, 15 centimeter. Then they leave it to design engineer, they decide. So, generally we discard penetration value for first 15 centimeter. Despite we discard, please provide. So, it will be very clear picture. So, first penetration 15 centimeter is 2 n value, second 15 centimeter is say 4, third 15 centimeter say 6. So, generally n uncorrected should be 6 plus 4, it is 10. So, instead of providing n corrected to all, you just provide, sometimes they provide 3 n values, every 15 centimeter n values. That is also another way. It will be easier job for sometimes design engineer, sometimes field engineer. What happen, the n if it is a 2, we say that first initial penetration below for 15 centimeter, we generally take it, we generally discard because it is kind of soil is loose and it will act as a setting load, but sometimes fast 15 centimeter penetration below, sometimes it gives 6, that means you cannot discard. So, it will help the design engineer see the complete profile of n value, instead of giving only one n value of 10. The design engineer can want to see complete n profile value, that will also helpful for design. Now, this is about your field test report. Whatever I have shown you, this is about your field test report, SPTN and moisture content, where you collect your sample, you collect sample at what depth, and whether it is a disturbed sample you collect, undisturbed sample you collect, where is your water table, and general soil classification. This is annexure 1, general soil classification, you say silty sand. Whether the general soil classification is correct or not, that is again a question mark. Means you have done this classification based on your laboratory test, remember. That means you have to provide all the laboratory tests in the report also, because this design engineer also they can check, cross check whatever calculation you have done, whether it is correct or not. So, to supplement this, once you say that it is silty sand, to supplement this silty sand, you have to provide, this is your data, complete summary of laboratory test data, that has to also attached in soft soil exploration. You see project number, as I said, date, this is the thing. Then first one is boring, where you have taken your undisturbed sample, boring 1, boring on 2, where boring number 1, boring number 2. In boring number 2, what is your depth and sample you have taken? Depth 4 to 6 meter you have taken sample, sample number always you provide. If it is number 1, you write number 1, 2, 3, 4, 5, 6 like this, sample number to be there, here sample number is there. At what depth you collect your undisturbed sample? Say at depth of 4 to 6 feet you collect undisturbed sample, 13 to 15 feet you collect undisturbed sample, this has to be clearly mentioned. Then type of material, you say that, see grey, the moment you use grey, then here grey, dark grey, these are all visual appearance. As I said last class, means visually you see this soil, visually you see and you identify whether a grey, dark grey, white, red or brown, that should be come here. Then this sandy clay, look at here, this sandy clay is nothing but your classification. It has come from your classification, even if here sandy clay, here it is silt, clay with silt, these are the things. Then definitely your natural moisture content, as I said, you find it out natural moisture content. Then most important parameter that you will provide density. When you collect the soil sample, how do you measure the density? Field density. The moment you collect the tube from the ground, this is your tube, this is your tube, it has been sealed at the top and at the bottom it has been sealed. So, with this sealed tube, you find it out what is the weight, and dry it, find it out what is the dry weight of soil, means find it out the weight, then make the soil sample out. You know this is your weight of soil plus this mold, soil plus this mold, you know the empty weight of mold, then you find it out what is your weight of or mass of soil, mass by volume, that is your density. You will get it in directly your density of your undisturbed sample collected, you can get it. So, every step this density has been it has been recorded. If you look at here, density has been mentioned. This is detailed laboratory data. Then once you density mentioned, then you go for sieve analysis data, classification data, as well as Atterberg's limits. Atterberg limits for what? It is for fine grained soil classification. It is for fine grained soil classification. If you look at here, liquid limit, plastic limit, plasticity index, everything, write it. Liquid limit you calculate from the laboratory, plastic limit from where you find it out, this plasticity index. This is all about classification data, then your real engineering data, engineering property or strength parameter C and phi. How do you get this, where you will give it from here? If you look at here, compression test means either you go for triaxial test or direct shear test, from where what is your compression, what is the strain. That means at this strain, this is your failure load you are getting. So, this strain, this is your failure load you are getting. Then also you give lateral earth pressure. Lateral earth pressure means that is your K0, lateral earth pressure at rest. From where you will get it K0? As I said earlier, from your dilatometer, pressure meter, you can find it out your K0. This value you provide your K0. Now, type of failure, what kind of type of failure you are getting from this? Then other test. Other test means you can say that from the classification set, if you look at here, 53% pass number 200 SIF. It means 50%, 53% below, 47% is finer, soils are finer. Everywhere else you provide it, every alternative. Then also consolidation data, other data also they have not done it. If you do it, you provide is also consolidation data, CV, coefficient of consolidation. Then provide coefficient of permeability, provide your coefficient of permeability, how much permeability, what is your coefficient of consolidation. This summarize means it is in summary form, like this called data sheet. These are called data sheets. It has to be attached at the end of your project report. So, page 1, page 2, page 3, page 4, either you provide for one boring, each boring one data set, second number of boring another data set, or you can combine depending upon how you want to provide them. But this is necessary and it is a must for geotechnical engineer to provide once you do this soft soil exploration. This is another way of representation. Look at this, this is another way of soft soil representation. You see, if you look at here, here it is written proposed foundation, the recommendation has been given. If you look at here, they have made a map. This way also you can provide, like make a single line, they have written borehole 1, B1, B for borehole, 1 for first borehole, B2 borehole 2, B3 borehole 3, B4 borehole 4. So, all the borehole they put it, just overall they are showing. Then elevation, elevation means during the survey where the ground is lying from the mean sea level, then they put it 1, 2, 3 means 1, 2 means different types they put it 1, 2, 3, 4, 5, 6, 9, 10 up to this they provide it. 1, 2 means top soil. What is the top soil? It is steep clay, they mark it. If you look at here, why I was saying just before, I was saying that the soil profile may change. Look at here very clearly. In borehole 1 and borehole 2, there is not much change. If you look at here, steep grey clay, it is up to 550 elevation here, and borehole 2, it is also 550 elevation, same soil is there, fine. Now, the moment you go to borehole 3 and borehole 4, look at here, the steep grey clay is there up to 560 of your elevation, then between 560 to 550 sand gravels are available. Look at the how the profile varying. You cannot say that with a single borehole or maybe 2 boreholes the soils will be same. Look at these 4 boreholes, borehole 1 and borehole 2 are identical, completely identical soil profile. The moment you go to borehole 3 and borehole 4, the sand patches, sand gravel is very less in borehole 3 and borehole 4 is, it is more wider. This is the basic difference as far as the design is concerned, because why these things I am discussing again and again, you have to decide where you are going to lay your foundation. This is your building, at what depth below the ground surface you want to construct the foundation, so that above the foundation the building can be erected, because this foundation, if it cannot rest properly in the soil, this strength whatever you are going to get to resist the load coming to the structure by means of soil. What will happen if this whatever this, suppose this total load coming to the structure, let us say 1000 ton or 10,000 ton is your proposed structure load. That means, if this is a building, how much load in this building is about to come. Suppose this building is about to take, imagine where you are standing, I am sitting in a room, this building is going to take, what is the load this building will, with this building there are lot of chairs, people will move around, and this complete wind load, dead load. Suppose this building has a load of 1000 ton. So, definitely this building, how it will resist, this load will be transferred from superstructure to substructure, then to foundation, and foundation will be acted by 1000 ton. If this 1000 ton foundation will take the load, who will take this load 1000? Obviously, this will taken by the soil. By what? By means of strength parameter, your C and phi. If your C and phi is not, value is not large enough, then it is not going to take. So, what will happen? The building will collapse. That is why this bore holes has to be cross checked with each other. So, if you look at this 1 and 2, go to the third and fourth, here you are getting a sand gravel, small patches. If you go to fourth borehole, look at here, the patch will be more. So, this is the basic difference. Instead of laying footing here, because footing it is a steep clay, fine grained soils are more. If I bring back footing slightly down, so it will lay in a foundation over the sand soil, where it can resist more load than your clay soil. So, that is why this bore holes and interpretation is more important for design engineers to decide all these things. Then another part, if you look at here, another major parameter is varying. If you look at here, where exactly your bed means particularly rock surface, is it in the shallow surface or is it in the kind of deep surface. Bed rock has to be located. Also water table, is this water table varying from borehole 1, 2, 3, 4? If you look at here, water table is absolutely not varying, it maintains constant depth, that means it is fine. Water table is not fluctuating. Your conclusion is water table is not fluctuating. Sometimes what happen, water table here somewhere else, because of the soil profile. So, now third part is, where is your bedrock, whether this foundation is a shallow foundation or deep foundation, depending upon the soil profile you have to decide where you want to provide your foundation, it is at the shallow depth or deeper depth. If you consider these two layers, I do not think your foundation, because this is a fine grained soil, silty grey clay, so it is not possible for a shallow foundation. Then in that case what will happen? You look for other alternative arrangement. What other alternative arrangement? Other alternative arrangement is your kind of deep foundation in the form of pile. The moment you go for deep foundation in the form of pile, then you want to locate somewhere else, some hard stratum should be there, either sand, gravel or bedrock. If you look at here, look, this bedrock is varying at an elevation 540, almost 540 to 535, the bedrock is varying. Bedrock is not supposed to be uniform. It is not necessarily that bedrock will be kind of uniform throughout. No, it may vary in this way, it may vary in this way, maybe it may be constant throughout. So, bedrock in this case almost kind of a uniform depth you are getting. That means, if you want for a deep foundation, it will be helpful. The pile can be resisted over the bedrock. So, the moment the load will transfer from soil to foundation to who is going to take the load? The load will be taken by either soil or bedrock. So, this is the philosophy how means particularly this interpretation is kind of a judgment over the period of time as an engineer. If you have experience over the period of time, your judgment will change from time to time. More you experience, more filter judgment you can provide. So, to be safer side, to be honest, to be safer side, if you have a crust borehole nearby like this, if I have done only 2 boreholes, I can say, oh, soil profile is steep clay or maybe grey clay, here is grey clay, that is fine, that means there is soil profile is uniform. No, look at the borehole 4, in this grey clay some patches are there where you are getting of a sand and gravel, maybe who knows, maybe borehole 5th borehole it may be completely changed soil profile. It is based on your judgment whether you are going to do or not to do, how to interpret, how to means how to give the result, so that design engineer should not face any problem. This is your first part, as I said, I means yesterday also I explained. This is your first report, first page 1 bore log data, simple depth, type, penetration and your classification. Page 1, this is your, if possible in second attachment, in second profile if possible give penetration blows every 15 centimeter blow, 15 centimeter depth, then you can show this how the soil profile is varying, how water table is varying, what is your bedrock, small diagram you can provide. This is your page number 2, and page number 3, 4th onwards, first one you give summary of detailed laboratory test data including all CV, K, all the laboratory tests whatever we explain. If you have done your also cyclic test, shear modulus also you can provide, how it is varying the shear modulus. Also soil stiffness value, soil stiffness is your E, mu, G, if you have done this test also you want to incorporate, then you can provide every depth wise. This is your detailed summary of laboratory test data, this is your third part. Then fourth part is your detailed summary of your field data, if you have done any kind of field test, like here it has been done standard penetration test. So, fine, if instead of standard penetration test, if somebody has done cone penetration test, that is fine, or if it is cone penetration test instead of standard penetration test, you show that CPT value, cone penetration test, how this penetration resistance is varying over the depth. That means, if this, what does it mean this diagram? I am showing there are 2 diagram of cone penetration, one is like this, one is like this. What does it mean? The cone penetration resistance value is constant over this depth of the soil and it is varying abruptly from here to here. That means, the soil property expected to change from this depth to this depth. Here also from at this shallow depth the soil property is changing, but here almost resistance value is same. Whatever field data you have done, you have to show in the fourth part. The first is your laboratory summary, fourth is your field summary. Also, if you have your shear velocity data, shear velocity data, variation of shear velocity for dynamic property, that also you show in a diagramming. So, this is your fourth part of these things. This is completely end of how to report your laboratory test data and field test data from for these soft soil explorations, how the report to be represented. One more lecture I am going to show from this field test data how to predict your earthquake resistance, that is your next class. Thank you.